legal LLMs, reasoning, and thinking. Across legal workflows, the models that matter most right now aren't always the newest or the largest, but the ones that follow instructions reliably and encode enough Western legal knowledge to draft and revise with nuance. Hands-on evaluations from the field put Llama 370B near a sweet spot for accuracy and drafting fidelity, with Gemma 327B showing good latent legal knowledge but weaker instruction following. Qwen 3's newer instruct variants are fast yet inconsistent on subtle drafting and rationale clarity, while GLM 4.5 Air and even GLM 4.6 can trail unless you explicitly trigger their chain of thought modes. GPT-OSS models, 20B, 120B, stand out on knowledge and instruction following, if you get past their guardrails, producing very on-point redrafts when the prompt affirms attorney oversight. Qwen 3 235B can match or exceed GPT-OSS 120B quality, but may run at 5 tokens locally, making it a reserve model for deep work rather than everyday drafting. Practitioners emphasize pairing models with RAG for statutes and local documents. For small jurisdictions, in-context evidence tends to beat parameterized knowledge. The caveat everyone agrees on: persuasive tone isn't proof. Review by a human remains non-negotiable. Reasoning benchmarks echo the theme. Family Bench, a long-context 400-person family tree test, now shows Gemini 2.5 Pro on top, 81.48%, Claude Sonnet 4.5 surged into second, 77.78%, and GLM 4.6 jumped dramatically after enabling its thinking mode. Qwen 3 Next 80B A3B, thinking broke 70% but often spends many tokens reasoning, and Qwen 3 235B, thinking sometimes thinks forever, consuming its budget before answering. GPT-OSS 120B scored 50.26%, comparatively efficient in tokens but behind the leaders on these multi-step inferential questions. The author also flags provider variants via OpenRouter, a fair warning that operational settings, like explicitly prompting thinking, can swing outcomes. Research is racing to make thinking both better and cheaper. Princeton's RLMT, language models that think chat better, packages code for SFT, DPO, and RL, PPO, GRPO, to train models that generate and then evaluate their own intermediate reasoning with benchmarks and datasets released for replication. The aim: capture the gain seen when models are allowed to reason, while keeping answers concise and on target. In parallel, a new web agent RL method, Tree-Guided Preference Optimization, TGPO, structures the agent's exploration like a tree, aligning preferences toward robust behavior under the chaotic realities of the web. These strands line up with empirical results like GLM 4.6's leap when thinking is prompted explicitly. Architectures chasing longer context. Architectural bets continue. Inclusion AI's RingFlash 2.0 104B swapped standard attention for linear attention, advertised for up to 128K tokens and post-trained on 1T tokens. The promised trade-off is clear: cheaper inference at high context and potentially better long document steering. Early users describe sharp reasoning and strong instruction adherence, though the provided chat template needs tool calling tweaks. The catch: novel architectures can lag on ecosystem support. RingFlash 2.0 linear isn't yet runnable in llama.cpp. A separate Bailing MOE v2 path is close to landing, and Qwen 3 Next gated DeltaNet is different again. GGIFs may appear, but they don't guarantee runtime support without kernels and loaders updated for the exact attention type. Expect months, not days, for broad compatibility. Benchmarks and anecdotes reinforce why these attention experiments matter. Linear attention aims to keep inference predictable as context scales, and multiple users are probing speed-quality trade-offs against Qwen and Llama baselines. One practitioner reports Ring's mini and flash variants are easy to steer and non-sycophantic, a prized behavior in production, though the included template needed reverse engineering for reliable tool use. Tooling friction remains real. An LM Studio load failed with Bailing Mo linear not supported, and a GGUF for a standard attention sibling predictably didn't run without upstream architectural support. The message for builders: check the whole toolchain, not just the model card. Local stacks, serving choices, offline research. Infrastructure choices are getting sharper edges. Llama dropped AMD MI50 GFX 906. Support after crashes with Rock Blast builds. effectively disabling a budget-friendly 32GB card many still deploy. Community members point out llama.cpp runs MI50 fine. Recent PRs even improved performance, and accuse Ollama of shipping binaries with GFX 906 data removed rather than fixed builds. The practical workaround from operators: replace Ollama with llama.cpp or kobold.cpp as the backend, OpenAI-compatible servers, especially when pairing with OpenWebUI. In MI50 land, prefer HIP CLBLAST backends, modest quantization Q4-Q5, smaller context, and avoid VLLM TGI paths with spotty RockM for older ASICs. The broader sentiment: if you need legacy AMD or flexible kernels, llama.cpp is still the safer bet. On the orchestration side, turnkey stacks are improving. Coexist AI added a Docker setup with a one-script deploy that bundles research, web, YouTube, Reddit, Git, local files, page video summarization, newsletter generation, plus new text-to-podcast and TTS pipelines. It also integrates local LLMs embedders to let small teams assemble Perplexity-style research engines without bespoke DevOps. For document generation at scale, an MCP-compatible streaming HTTP server just landed in the MCP file generation tool v6.0. The release consolidates its toolset down to two primitives: create file, generate archive, adds Pexel's image support and professional office templates, and works out of the box with OpenWebUI 0.6.31, no proprietary MCPO key needed. These are small wins that compound into fewer moving parts. One clever cost lever: push deep research offline. A community fork of Landgraph's Open Deep Research routes historical general lookups to a local Wikipedia index to /web calls. Practitioners recommend a hybrid: BM25 via Elasticsearch for first-pass recall, a local re-ranker, e.g. B re-ranker, to sharpen results, and only then vectors in Qdrant for long-tail queries. Index raw wiki text rather than ZIMs for better search, chunk by section headers, keep infobox leads separate, and store Wikidata QIDs to prefetch related hops without touching the web. In K8s, run indices as separate pods with mmap to minimize memory churn. The pattern is straightforward RAG economics. A cheap lexical gate preserves quality while cutting bandwidth. Voice, local ASR, and ultra-cheap TTS agents. There's a flurry of voice tooling that bends the cost curve. One open repo claims a hyper-cheap voice agent, over 30 times cheaper than 11lab/OpenAI Realtime, aimed squarely at real-time conversational apps. It's early, but the direction is clear. Push latency down and prices towards zero for interactive speech. On-device ASR is catching up fast. Myvi, my AI voice input, delivers real-time transcription with a global hotkey, streaming overlays, and clipboard copy, all CPU only by default. It uses NVIDIA's Parakeet TDT.6b, achieves 6.36 times real-time on CPU, 7s audio and 2.5s, and stitches overlapping chunks to avoid mid-word cuts and duplicates. For privacy-sensitive or air-gapped setups, that's a substantial usability upgrade over heavier whisper stacks. Meanwhile, a compact multilingual TTS model, Canny TTS 370M params, targets sub-second perceived latency by generating codec tokens with a small LLM and decoding via a neural audio codec. Benchmarks claim once to synthesize 15ths of 22 kHz audio on an RTX 5080, MOS 4.35, and WAR 5%, with voices across English, German, Chinese, Korean, Arabic, and Spanish under Apache 2.0. It's optimized for NVIDIA Blackwell, but small enough to consider edge servers, useful for assistants that need snappy speech without cloud bills. Apps meet context MCP and ChatGPT SDKs. Distribution is consolidating around where users already work. One editorial argues the new ChatGPT app SDK doesn't kill small AI startups, it filters them. Thin wrappers will suffocate. Tools that deliver real workflow value, analytics, compliance, domain logic, gain an on-ramp to massive distribution with built-in auth, context, and discoverability. The advice is pragmatic. Stop forcing users into new tabs and meet them in the interface they already trust. Technically, that consolidation rides on the Model Context Protocol, MCP, an open JSON RPC 2.0 base standard for connecting assistants to external tools, data, and services. A comprehensive tutorial for ChatGPT's developer mode shows how to add custom MCP connectors, implement required endpoints, including search and fetch, add production OAuth 2.0 with PKCE, deploy the server, Fly.io recommended for root domain control, and debug edge cases. Taken together, Apps SDK plus MCP lowers friction to bring back-office systems to the chat surface with strong auth, structured tools, and shared context. MCP is also surfacing beyond OpenAI's walls. The new file generation tool supports MCP streamable HTTP out of the box, speaking the same contract to Open Web UI and similar front ends. That's what a standard is supposed to do. One way to declare tools, one way to call them, regardless of the chat client. Security, messengers, networks. A sobering first for robotics, a wormable exploit chain across Unitree's humanoid and quadruped lines. Researchers detail a BLE Wi-Fi config service with hard-coded cryptographic keys, a Unitree password handshake, and unsanitized input concatenated into shell commands, ultimately yielding root. Worse, compromised robots can infect others within wireless range. It follows the classic disclosure arc: notify vendor, wait, publish mitigations when fixes stall. But the implications are broader. Connected robots are computers with legs, and their security debt is now everyone's problem. Messaging is bracing for the post-quantum era. Signal outlines Signal Protocol and Post-Quantum Ratchets, SPQR, advancing work to keep end-to-end encryption resilient against future quantum adversaries. Transitioning ratchets without breaking usability is non-trivial. Shipping it safely in the wild is a milestone the broader ecosystem will track closely. Networks are converging in ways that stretch threat models. A telecom security webinar spotlights how LTE 5G and satellite infrastructures are intersecting. Think Starlink broadcasting LTE and emerging non-terrestrial networks, expanding the attack surface across space and ground segments. Lessons from breaches in both domains and the governance question of who secures what are front and center. Section: Research and Systems, Time Series Vectors, Silicon. Beyond text, Google's TimesFM25, PyTorch, is a decoder-only foundation model for time series forecasting. The open checkpoint includes code to produce point forecasts and quantiles, continuous quantile head, crossing fixes, with configs for context horizon lengths. It's pre-trained on Wikimedia page views, Google Trends, and synthetic augmented data through late 2023. The example API is straightforward and suited for stacking into analytics pipelines or, increasingly, agentic planners that need uncertainty-aware predictions. Under the hood, acceleration work continues. Flash K-means implements exact batched K-means in Triton, delivering large speedups over standard PyTorch on H100s in common regimes, e.g. 16K points time 128D 1K clusters, batch 32, FP16. It comes from the sparse Video Gen 2 effort, but the primitive is broadly applicable. Faster clustering can shave minutes off embedding deduplication, vector quantization, or retrieval pre-processing. Every bit helps when you're wrangling millions of chunks. On Silicon, Xiangshan's vector FPU design notes are a solid reference for anyone mapping RVV 1.0 floating point. The VFPU spans FP16, FP64 with modules for add, ALU, VFALU, FMA, VFMA, div, squirt, teat, and conversion, VFCV, and tackles two hard problems: maximizing lane bandwidth for multiple single precision ops, e.g. 4TIM FP16 per 64-bit lane 2FP32, and supporting mixed precision ops mandated by RVV without blowing timing. The microarchitectural details: dual path addition, vector FMA div algorithms, sequential accumulation, show how to keep precision flexible while staying fast. Learning from coding sessions automatically. Developer ergonomics are also improving. A small but useful tool, Learn and Vibe, mines Claude Code chat histories to surface where time really goes. Recurring debugging themes, API assumptions, layout recalcs, missing error handlers, quick win patterns, and reusable snippets you've already solved. It runs locally, SQLite plus Next.js PWA, and uses the Claude Agent SDK for analysis. Next on the roadmap is auto-generating a Claude.md with rules tailored to your gotchas, so the assistant can preempt your favorite mistakes. It's the kind of feedback loop junior and senior engineers alike appreciate. Less vibe coding, more deliberate practice.